This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. Guys, this is our day one and today we will be going to discuss about big data basics. Before moving ahead, like I want to tell you, like from where this big data word came and what is the what are the different significances that are given by big data. Now, starting from the processing perspective, in this particular world, there are two types of processing: monolithic way and distributed way. So, say we are having certain data and we want to process that particular data. So, what I can say, data. Guys, please go on mute. Data. So, data that is nothing but collection of facts and figures. Facts and figures. Please go on mute. Okay. Okay. Thanks, Vikas. So, what we are going to cover big data basics. And big data basics, like if we are going to divide this particular word, big data, so that is the combination of big and data. Okay. Which is denoting the data in huge size. But that is not the official definition. And before moving with the official definition, I just want to tell you like how the data is being processed in this particular world. Now, data data is nothing but collection of facts and figures, and once we are having huge amount of data that is there, then it is called say big data. But the main challenge, once we are having data or huge amount of data, say big data, then there are two challenges. One is storage and second one is processing. Okay, once we are having huge amount of data, then storage and processing, these are the two challenges. Like we need to store this data somewhere, and until unless we are not processing the data, we will not be able to get any information. Okay, so information is what? Processed data. And what exactly information is, say we are having certain students in a class. Okay, we are having some students in class, that is nothing but a data. Okay, some students inside the class. But once we are saying we are having 30 students inside the class, so that means we have processed that particular data, and that is giving certain information about numbers and all, or tangible information. So that is called information, and information is utilized in order to boost the revenue, boost the business. Okay, so processing is mandatory. Until unless we are not processing the data, then we will not be able to get the outcome. Okay, so processing is mandatory. So what I am telling, once we are having data, then storage and processing, these are the two challenges. Now now if we are talking about the processing or storage, so there are two ways, monolithic way, or we used to say traditional way, and second one is distributed mechanism. Okay, distributed mechanism. Okay, so monolithic is what? Once we are processing the data with single machine, then that is called monolithic way of processing or monolithic way of storage. Once we are storing with single machine is called node computers. Okay, uh, processing data with single machine node. Okay, so if we are handling the data, guys, please go on mute. Okay. Okay, so once we are processing the data or handling the huge, or once we are storing the data or processing the data with single machine, single node, then it is called monolithic way. Okay, there are certain challenges once we are processing with the single machine. So the challenges, what are the different challenges? Say if the data is huge in size, that is not able to fit inside the storage. For an example, if I'm having 5 TB data and I'm having the disk size that is uh, capable to store 1 TB data, then what I can say, that machine, that node or the computer is not able to handle, is not able to store 5 TB of data. So inside the monolithic way, these are the challenges. It is not if the data is increasing with huge size, then it is not able to handle. Second thing, scalability. Challenges with monolithic way. So one is not able to handle huge amount of data. Okay, that is the first challenge. Second one is scalability. Scalability. So if we are having say I'm having this particular machine that is P5 system, and it is having 512 GB of disk. Okay, 512 GB of disk is there in this particular machine, in this particular laptop. Now if I am going to increase the disk size by 1 TB, I will be able to increase, that is fine. But if I want to increase it up to say 10 TB, then it will not be possible, because there is the limitation. Okay, like this particular motherboard is not able to handle 10 TB of disk. It is not able to handle. So scalability is a challenge. We can scale up to a certain limit. Beyond that limit, we will not be able to add hardware or increase the configuration of this particular machine. So once we are talking about scalability, then there are two types of scalability. Horizontal scalability and vertical scalability. Okay. Horizontal uh, size can be increased. Okay, so horizontal scalability, you can think in this particular way. Say I'm having a particular node or a particular machine. If I'm adding more machine in a particular cluster, then that is horizontal scalable. And vertical scalability, if I'm going to increase the capacity of a machine. So scalability, horizontal scalability is not possible once I'm working in monolithic way, because I'm working with single machine. I'm not looking for a particular cluster. Okay, I'm not having a cluster over there. So horizontal scalability is not possible, huh? Not possible, what I can say. Okay, only vertical scalability is there, and up to a certain limit, because beyond that particular limit I will not be able to increase the configuration of a particular machine. So monolithic way, like, this is vertically scalable, but up to a certain limit. Beyond that limit I will not be able to increase the hardware. So monolithic systems or nodes, these are the traditional way of handling or processing the data. These are vertically scalable, and these particular nodes are not able to handle if the data is increased in huge size. Okay, up to a certain threshold these particular machines are working good, but if, like, these particular machines are having huge amount of data, these machines will not be able to handle, huh? Like, single computer, or in a single computer I will be able to process up to a certain limit. Beyond that limit I will not be able to process, huh? That is the issue with monolithic way. Now, one benefit is there. Once I'm working with monolithic systems, at that moment the latency is very much low. Okay, because I am dealing with low data, less data, okay, low amount of data. And once I'm dealing with less amount of data, then the processing will be good, because this particular machine is able to handle that particular data. So monolithic way there will not be any challenge, huh? But challenges are there if the data is increased. If I'm looking for the scalability, okay, what horizontal scalability, vertical scalability is possible up to a certain limit. Okay, then I need to look for the another solution, that is the distributed mechanism. Once we are having huge amount of data, at that moment we are having distributed systems. And over here the basic principle is, like, we are adding multiple machines in order to store and process huge amount of data. For an example, say if I'm having 5 TB data and my laptop is able to handle, say, 400 GB data, my laptop, uh, I need to deal with 5 TB data, and machine laptop is able to handle 400 GB. Yeah. So 5 TB is there that I need to handle, that I need to manage, and my machine capability is to handle 400 GB data. So what I need to do, uh, 5,000, that is 5,000, around 5,000 GB divided by 400. Okay, so it will be around 12 or 13, I can say 13 nodes, so I need to have 13 machines of this configuration, of my machine configuration. Then it will be able to process and store this 5 TB of data. Okay, that is the basic principle, like adding more machines, adding multiple machines for processing the data, the processing oblique storage, the huge data. Okay, so distributed mechanism, once we are adding multiple machines in order to process or store huge amount of data, so at that moment what will happen, then I will be able to handle huge amount of data. Second thing, the scalability, yeah. So the machines will be horizontal scalable and vertical scalable. I can increase the configuration of a machine, and I can add more machines. Say uh, today I am dealing with 5 TB of data, then it is managed with 30 nodes, that is fine. But tomorrow, like if the data size has been increased to 6 TB, then what I need to do, either I need to increase the configuration of my laptops or the nodes which are there inside the cluster, or I need to add more machines. That is nothing but horizontal scalability. Yeah, you can think in this particular way, like uh, inside Delhi, we are having multiple low-rise floors. That is like, in order to cater the populations, we are having multiple independent houses. So that is uh, somehow like horizontal scalable, like Delhi is spread horizontally. But if we are talking about Mumbai, okay, so over there, like we are having high rise buildings, so over there, in order to cater the huge population, then vertically, like inside small geographical area, we are having high rise building. That particular building is going to cater the population, so that is vertically scalable, so increasing the capacity of a particular machine, that is vertical scalability, and adding more machines or nodes inside the cluster, that is horizontal scalability, yeah? So this is the way how we are going to deal with data in order to process and in order to store. So in 2003, what was happened? This particular problem was observed by Google. Google was looking for the solutions, like it has observed that the data has been increased in huge size, and the machines which were available at that moment, those particular machines were not able to handle that particular data. Okay, so they have observed the issue, like the current configurations of the machines are not able to handle uh, storage and processing related challenges for the data which was there at that moment, so they were looking for the solutions, like if the data is increasing day by day, and what we need to do in order to solve the storage and processing related challenges. So in 2003, Google published a white paper, and it was having a solutions like how to store huge amount of data, that is how to store huge amount of data. Okay, how to store huge amount of data. This was the white paper which was published by Google in 2003, yeah. So it was saying like adding more machines in order to store huge amount of data. Okay, so what I have mentioned, there are two challenges once we are having huge amount of data. One is processing, and second one is storage. These are the two challenges once we are having huge amount of data. So in 2003, Google has published a white paper how to store huge amount of data. But I have said, if we are going to store the data and we are not having the capability of processing the data, then that is not making any sense. We need to process. So in 2004, again they have published another white paper, and that is like how to process huge amount of data, and like that is also based upon adding more adding more machines. Like instead of processing with single machine, We need to deploy more machines for processing the data. So they have given a name to these technology. So 2004, 2003, they have given a name or suggested a name, Google File System. Google File System. They have given a name to this particular solution, Google File System or GFS. GFS. Like if you are looking for storing huge amount of data, then Google File System is the solution. Over here, what we are doing, we are deploying more machines in order to handle huge amount of data. Okay, that is fine. Then in 2004, they have suggested the solution in order to process huge amount of data, and they have given a name called MapReduce. That is the combination of two words, mapper plus reducer. Okay, mapper and reducer. So MapReduce is the solution in order to process huge amount of data. But these were the white papers only. These were the white papers only. And white paper is a suggested solution in order to tackle with a particular problem. This is not the 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 end product which is capable of handling or solving the issue. This is going to suggest a solution. The product is or the solution is not developed yet, but they are just suggesting the way how to solve a particular problem. So these were the white papers only. The solution was not available. They have given certain outline, like you will be able to store and process huge amount of data if you are working in this particular direction. If you are working with Google File System, the way how the Google File System is going to solve or kill this particular issue. So these were the white papers only. A, a man was there named Duck Cutting. Duck Cutting was the name, and this particular person was looking or uh, was going through with the solution which was or the white papers which was published by Google. So Duck Cutting has gone through with the solution which was suggested by Google. So based upon these particular white papers, he has developed a solution named as Hadoop. Okay, so Hadoop is based upon the white papers which was published by Google in 2003 and 2004. So in 2006, Hadoop came into the picture. Hadoop, that is the distributed way of processing and storing the data. Okay, so inside the Hadoop, what I can say, that is going to deal with two main problems which we are having with huge amount of data. That is storage, how to store huge amount of data, storage and processing. These were the two basic problems which uh, were available with huge amount of data, with big data, what I can say. So storage, so for storage, for storing huge amount of data, he has developed a solution like Hadoop. And for dealing with storage, he has given a name to the solution HDFS, that is Hadoop distributed file system. Distributed file system. Okay, HDFS, what I can say. Hadoop distributed file system. So this is the solution which is based upon GFS, Google File System, and this is the same what we are having in Windows. Okay, like FAT32, that is file allocation table, that is a file format. We are having NTFS, that is new technology file system, how the data is placed or maintained inside the storage. Okay, I'm having a disk in this particular laptop, so how the data is maintained, that is driven by NTFS, because I'm having Windows operating system, and Windows operating system is having NTFS file format. So NTFS is driving how the data is placed inside the disk of this particular machine. So say in the same way HDFS is working, that is driving how the data is placed inside the Hadoop. Okay, so they have given this name SDFS, how the data is stored in distributed way. Okay, how multiple machines are clubbed together in order to store huge amount of data. Okay, HDFS. So HDFS came into the picture in like Hadoop came into the picture, and inside this we are having HDFS that is driving how to store huge amount of data. That is perfectly fine. Now what we need to do, we need to process this particular data. Okay, processing. So duck cutting has kept the same name which was given by Google, and for the processing perspective, MapReduce is the technology, what I can say, uh, available that is available inside the Hadoop in order to process huge amount of data. Now, this is the same, like if I'm allowing, if I'm saying, say we are having 10 people and 10 people need to break 10 sticks. So then like one stick is broken by one a person. So within say, what I can say, we are having 10 sticks and 10 person. Okay. And
Ashok,
yes, yes, yes.
yeah, sorry to interrupt. I have a query. This
Mhm.
Hadoop is a tool, and this MapReduce and HDFS are the technologies used in Hadoop. Am I right? Right?
Yes, 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 yes.
Okay, okay.
Okay. So technology is what like that is governing how a particular task is being performed. Technology
Okay,
is governing. You can take like I'm having uh, a car that is having jet engine. Okay, turbo engine basically. So turbo is
okay,
the technology which is used in my car. Okay,
okay,
and car can be say I'm having say XUV 700. Okay, that is
okay,
having turbo engine. So turbo is the technology. CVT 1.2.3 we are able to see on some vehicles. That is nothing but some technology which is opted, right? So
okay.
that is a technology basically, right? Clear?
Yes, yes, it's clear.
Perfect. So these are the technology basically. Okay, how the things are governed. So 10 sticks are there, and like 10 persons are going to broke those 10 sticks. So one stick is broken by one person. So that will be done. Say one stick to break one stick, it is like we need to spend 1 minute. So within 1 minute, all 10 sticks will be broken. But if we are having 10 sticks and one person is there, then one person, so that particular person is going to take 10 minutes. Okay, 1 minute. So what I'm going to say over here, like we are having distributed computing or distributed way of handling the task. Okay, each stick over here, like task is nothing but say one stick. So each task or each stick is divided into uh, this pool of person. Okay, like we are having 10 persons over here. On another side, what I can say, 10 tasks, 10 nodes. Okay, and say 1 minute. So over here, what I can say, 10 sticks, 10 person, 1 minute, 10 task, 10 nodes, 1 minute. each node is going to take one task and it is like able to complete in say 1 minute. So that is nothing but distributed way of handling the task. And over here what we are able to see, this is the monolithic way of handling the task. Only single person, only single node is there which is going to break, so that is going to take too much time. Okay, so nowadays we are having very huge data, and if we are going to process like with single machine, that will not be possible, or it will take thousands of years in order to process if we are processing in queues, or if we are going to process it in a sequential manner, like say I'm having 10 TB data or like thousands TB data, and my laptop or desktop or my node is able to process say 1 GB of data per day. So it will take like thousands of years or thousands of days in order to process that particular data if I'm breaking the data and going to process it with single machine. But that is also not possible, because for that for storage itself we need to have multiple nodes or the capability to store that particular data. So those particular things are there, but what I can say, this is nothing but the monolithic way of handling, and this particular stuff is nothing but the distributed way of processing. That's why like we have started our day like with monolithic way of handling the data and distributed way of handling the data. Okay, that is perfectly fine. We are having Hadoop in picture, and Hadoop is having HDFS and MapReduce in order to store and process huge amount of data. Okay, that is fine. Now,
So,
we are
Ashok,
talking.
one uh,
Yes, please.
Ashok, one question.
Mhm.
So, like that, I just want to clear again. Hadoop is a tool, or we just use two techniques or technology like for storage HDFS, for storage HDFS, and for processing MapReduced.
That is perfectly fine.
Hmm.
Okay, so Hadoop, why we are calling it a Hadoop? So once at the moment, once the duck cutting was working and he has designed this particular solution, he was looking for a name. Like what is the name that is going to give to this particular uh, product that he has developed? So his kid was playing with an elephant in his house, and his kid was saying Hadoop Hadoop. Like kids are used to say, his kid was saying Hadoop Hadoop. So he has picked that particular name, and he has given Hadoop as a name to this particular solution that he has developed in order to deal with huge amount of data, right? So Hadoop is the name which was which came because his kid was playing with a particular toy, and let me show you something. Mhm. Okay, so if you are able to see this diagram, Hadoop, this was this is the picture of toy that 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 was like available with his kid at that moment. So he has kept the same picture and the name which was like spoken by his kid. So Hadoop tool name came from the duck cutting sons. Okay, so this is a you can say small story which is there. So Hadoop is a solution that is used in order to process and store huge amount of data. We used to say Hadoop ecosystem. Hadoop ecosystem, and Hadoop ecosystem is having multiple components. Hadoop ecosystem. Let me show you Hadoop ecosystem. That is an ecosystem basically. Okay, if you are able to see Hadoop ecosystem, so in Hadoop ecosystem, this is from data flare. Okay, so HDFS is there. Just have a look over here. HDFS is there, that is Hadoop distributed file system. MapReduce is there. With just like see this particular data processing, Hadoop distributed file system, that is for storage. Yarn is there. We will be coming on Yarn. What is Yarn? We are having Zookeeper, Scoop, Flume, Uzi, Catalog. Okay, and Mahoth, Thrift, HBase, Drill. Okay, so many tools are there, or these particular like tools, what I can say, big, okay, that these are used in order to like deal with huge amount of data and going to perform a specific task inside the Hadoop ecosystem, right? So this is an Hadoop ecosystem. Okay, let me try to come back. Okay, so Hadoop, that is the combination of HDFS and MapReduce. Okay, and it is going to handle huge amount of data in terms of storage and processing. Yeah. Okay, now, okay, now we are able to say we are having Hadoop. We are having Hadoop, and from the Hadoop perspective, we will be going through with the different things, like say how to work with Hadoop, what are the different components inside the Hadoop. So once I'm saying say Hadoop, inside the Hadoop, what we are having different nodes, and or you can say collection of nodes. We are having multiple nodes or machine servers, that is the same thing. So we are having multiple nodes over here inside the Hadoop ecosystem. So say node and node and say node and node. So this is master and slave architecture. Hadoop is master and slave architecture. Slave architecture. Okay, inside Hadoop, what we are having? We are having master and slave. So this is the master, and these are the slave nodes. Slave nodes. Slave, that is slave. So we are having slave nodes. Slave node. So slave node, slave node. What we are able to see over here inside the Hadoop architecture, or what we are having a master and we are having different slave node. Because like once we are working with the distributed mechanism, this is the way like how to deal with huge amount of data in terms of storage and processing. So once we are having multiple machines in a particular cluster, then which part of the data will be stored in which machine, what I can say I'm having 1 GB data, 1 GB data, and I need to store this particular data in this particular cluster. And say over here, the first thing what I need to think, like say 1 GB is data is there, and if I'm going to put 1 GB data over here, then what is the benefit of distributed computing? If the data is placed inside one machine, then this is not the way how a distributed mechanism will work. What I need to do, I need to store 1 GB of data in these particular machines. So very first thing which is available inside the distributed computing, that is partitioning. 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 So what is the partitioning? Basically dividing the data in such a way so that that particular data will be available into different machines, or that particular data will be able to take the benefit of distributed computing. So for dividing the data, the basic principle is partitioning. This is like dividing the data in smaller chunks so that those particular chunks will be placed inside the different machines. So over here, like the frame concept came into the picture, and inside this particular frame or block, what I can say, so the data is divided based upon some finite numbers, and in Hadoop 1 we were having 64 MB block size, say block size 64 MB, and in Hadoop 2 we are having 128 MB. Yeah. That is the block size. So what we are doing over here, we are dividing the data in terms of block, and the block size is 64 MB in Hadoop 1, and in Hadoop 2 it is 128 MB. Yeah. Let me mention over here.
Mm, Ashok, what is Hadoop 1 and 2? Means these are
Uh,
versions.
yes, versions.
Okay.
Hadoop MB and Hadoop 2. Hadoop 2, that is 128 MB. Okay. So Hadoop 2, we used to say like say Spark 1, Spark 2, Spark 2.2, Spark 3, Spark 4. That is nothing but the versions. So there is certain advancement in Hadoop 2 in terms of blocks, in terms of like adding yarn. Okay, so because of like certain advancement, the Hadoop version has been changed, and we used to say Hadoop 2, Hadoop 3 as well. Okay,
So
so
Ashok, this is fixed block size or this is the minimum block size?
this is fixed block size in Hadoop 2, and this is
Okay,
fixed for Hadoop 1,
okay, okay. Thank you.
right? That is
Ashok,
fixed.
Ashok, hello,
Yes,
Ashok.
yes, yes.
Like Hadoop, you told like having the different nodes inside the Hadoop. Okay, so is there
Mhm.
any limitation? Like we can go with maximum node like limitation. Is there any
Yeah,
fixed
Hadoop 1
limitation?
was having the limitation. Once we are
Mm,
having the node size, the cluster size greater than 4,000 nodes, then it is not working in a good way. Okay, I will be
okay.
covering on that point,
Oh,
like
oh, okay,
the
okay.
bottleneck inside the Hadoop 1 in terms of node.
Okay.
Okay, I will be coming on that point. So Hadoop 1 was having the block size of 64 MB, and Hadoop 2 is having block size of 128 MB. And what is this block? Basically, what we are doing, we are dividing the data in such a way in smaller chunks so that it will be able to take the benefit of distributed computing. Now what we are doing, say I'm taking this, so one block is placed over here, Another block is placed over here, third block is placed over here, fourth block is placed over here, and one is here. Okay, 2, 12 for the, okay, I think 4 for 8. So suppose like 8 blocks are there in 1 GB of data. I'm taking hypothetically, probably like if we divide 1000, okay, so 1024 divided by 128. Okay, so we are having 8 blocks. That is fine. So 8 blocks are there, and I have kept 8 blocks. So 8 blocks are there.
So,
Uh,
Ashok, master node is not used for storing this data.
yes, yes, definitely it is not going to store any data. I'm
Okay,
coming on that point as well.
okay.
Okay, now what is happening? Why we need to have master and slave architecture? Okay, that is fine. 1 GB data is there, and I am going to divide the data in blocks, and I can keep these particular blocks into different nodes. Perfectly fine. It is able to store. But which machine is having which block? Okay, say in another words, this is say block 1. This is let me mention over here. Say B1 and B5 is available. B5 is available in this particular node. B2 and B4 is available in this particular node, and B3 and B6 is available in this particular node, and B4 and B8 is available in this particular machine. Okay, now one person is there, a client is there, and client is asking, say, I need to have B4. I want to have block for information. Okay, I want to have block for information. Then to whom it is going to contact? This particular client is going to connect with master node. He will say, hey master node, I just want to have the B for information, B for block from the data, 1 GB data. That is something like we are going to write the query, say select a star from table where say where we are having say employee name equal to abc. Okay, we are having such type of queries. So based upon the name, say partitioning is done, and abc information is stored in b4 block. It is not going to say I want to have b4 block, but it is going to say abc. Then internally the mapping will be done, and based upon that particular mapping, master node need to fetch this b4 block information from this particular slave. So this master node is going to contact with slave node 2, and let me mention slave node 1, give the numbering as well. Slave node 3 and slave node 4. So we are having 4 nodes, so it is going to connect with the slave node 2, and from this particular slave node it is going to fetch this b4 block information, and this particular block information will be shared with the client. Now the data, there is certain data which is maintained by the master node. That is something like, say b4 block information is available in a master node, that it is placed inside the slave node 2. So that particular data is nothing but metadata. Metadata. Okay.
Ashok,
And this is
Ashok, is there any fixed algorithm to partition these data among slave nodes?
that is taken care by Hadoop itself, Hadoop distributed file system. That is going to decide like how the data is placed among different nodes. Okay, no human intervention is there, like in order to place the data into available nodes. It is taken care by SDFS or Hadoop itself.
Okay, and the information will be stored in master node. That's
Inside the
how
master
this.
node.
Okay.
Okay, so this
Maybe some
particular
internal,
information.
go of Hadoop system
Yes,
will
yes,
work there.
yes.
Basically,
Definitely, certain algorithms are there which are working in order to store or
that
like
blocks.
those, yeah, those particular algorithms are governing the entire flow. There are certain racks mechanism as well. We will be going to cover rack mechanism. So I'm coming on that particular point. Let me open one presentation in order to visualize the things in a proper way. Okay. Okay. So we are going through with say nodes and different nodes are there. Cluster. We are storing the files. Okay. We came over here. So we have divided the data in terms of blocks, and these particular blocks we need to place. Okay, so I will cover with the presentation as well, but before presentation, I just want to walk you through with what are the different internals which are playing a role in order to move the data into different machines, or somehow the basics of algorithms which is available inside the Hadoop ecosystem. Okay, so client is there that is asking like I want to have this particular information. So it is given by the master node, and master node is going to maintain the metadata. Based upon the metadata, he is going to place. He is going to provide the information. So let me what we have discussed that you will be able to see over here. Okay, so we were having this 512 MB of text, and that is having say four block, and these particular four blocks are placed in these particular four nodes. And this particular information is maintained by master node. Say block 1 is available in data node 1, block 2 is available in data node 2, and block 3 is available in data node 4. Okay, so in Hadoop terminology, master node is known as name node, and slave nodes are known as data nodes. What we have mentioned over here, slave nodes, these are nothing but data nodes. We used to say data node 1, data node 2, data node 3 in the terminology of Hadoop. And master node is known as name node. Okay, so what we are having name node and different data nodes, and these particular data nodes are going to store the actual data. Okay, so actual data is maintained inside the data nodes or slave nodes, and metadata is maintained inside the master node or name node. To answer the Pankaj's query, so meta master nodes or name nodes are going to manage metadata. These particular nodes are going to handle with the actual data, and master node is maintaining the metadata. That is data about data. So actual data is over here. That is block 1, and it is available in data node 1. This information is maintained by master node. Moving further, so client came, he's looking for one block, then master node is going to connect with uh, with the data nodes, and then this particular information uh, is shared, and then client will be directly able to access from these particular data nodes. So that is the flow which we have already discussed. Now, the another thing that is there, like we are having block 1, block 2, block 3, and block 4. So if a
Okay,
particular block,
Ashok, you mean to
Mhm.
say that master node will reply to client about the node which is having the data that client is required. After that, client directly contact the data nodes
Yes, yes,
for the
it will
data. Eh?
be able to connect directly. Like there
Oh,
will be direct communication between client and the nodes.
okay,
Or direct link will be there, and the data transfer will happen. It will be with respect to processing and with respect to storage.
storage. Okay.
Okay. Now, one thing is there, if a particular data node is down, if a particular slave machine is down, then what will happen? Now, just think over here. We are having a particular node, and this particular node is going to maintain B1 information, block 1 information, and block 5 information. Now, we know it very well. Once we are dealing with multiple machines, or once we are having a cluster, it might be possible there is certain issues inside the cluster. One machine, there might be some communication related challenges, network related challenges. Okay, one machine is not available inside the network, or node failure. It might be possible there are certain hardware issues. It might be possible like these particular nodes are placed into different locations. Say one node is placed inside Delhi, another in say Mumbai, third one is say Australia, fourth one is say Singapore. So it might be possible these particular nodes are geographically on geographical apart locations. These are the servers basically. So there are the possibilities, they are placed onto the different geographical locations, and a particular geography location is having certain natural calamities, like say flood is there, and because of say flood, the node has been destroyed, and the data which is placed in that particular node, that will be will be say destroyed, that will we will not be able to recover that particular data. There might be certain situations, I'm taking an example, so how to deal with such type of scenarios once a data node is failed. So once a data node is failing, what we need to do? Okay, and what is happening? So the basic thing, like if we are placing the data in this particular way, okay, if we are placing the data in this particular way, what we are able to see over here, definitely this block one will be lost, and we will be having B2, B3, and B4, and there is like saying in the field of data engineering, or in the field of data, like incomplete data will provide you the false information. Okay, if you are not having the complete data, then you will not be able to get the actual outcome. So block 1 is missed, and you are having B2, B3, and B4. Four blocks are there. So how to tackle these particular scenarios? So what we are having a concept replication factor. So inside the replication factor, what we are going to do, we are going to create the replicas of block. We are going to create replicas, and those particular replicas are placed inside the different nodes. So say block one, so we will be having three replicas. Say block one is having three replicas. This is placed inside the this particular data node 1. B2 is having three replicas, B3 is having three replicas, and B4 is having three replicas. So we are having default replication factor 3 inside the world of Hadoop, and replication factor 3, that is saying say we are having three copies of each block, and if one copy is missed, then we will be able to recover or we will be able to work with the second copy. That is perfectly fine. Now just try to see this particular diagram and tell me, is this a good scenario in order to create the replicas?
No,
No.
this is not good scenario because we replicate same block in one node.
Yes, that
We
is
need
perfectly fine. Now, what will be the good solution? Say we are going to create three replicas. Say B1 block replicas are available in node 3 and node 4. One block is available over here, second replica is available over here, and third replica available over here. In the same manner, what we are having B2, and B2 is maintained in data node 1, data node 2, and data node 3, and B4 is maintained in block data node 1, data node 2, and data node 4. So what we are having the replicas of each and every block, and those particular replicas are placed into the different nodes. Now just try to think, if a particular node is lost, then we will be able to recover it from the different node, right? Right?
Yes.
yes,
Perfect.
yes,
Now,
yes.
how the metadata is maintained? This particular stuff is maintained inside the master data. Say B1 block is there, that is available in data node 1, data node 3, data node 4. B2 block is there, that is maintained in data node 2, data node 1, and data node 4. So, based upon this particular diagram, what we can say, with the help of replication factor, if a particular node is down, then we will be able to recover the information or data from the nodes which is containing the replicas of that particular data. Perfectly fine. Now just try to
Okay,
think.
Ashok, one
Hmm.
query. Why this default replication factor is 3?
Yeah, you can change. Default is something which is given by Hadoop.
Okay, means we can change it. Huh?
Yeah, you can change it to 1, 2, 3, 4, 5 based upon
Mm,
your wish.
like you can understand from the default parameter, you can change
Yeah.
even eventually.
Okay. Okay. Okay,
Yeah,
and
perfect.
one more thing. These replica distribution will be done by Hadoop ecosystem itself, or
Yeah, yeah.
master node will
Hadoop is
decide.
playing, Hadoop algorithms
Okay.
are playing role in order to distribute the replicas, and distribution will
Okay.
happen based upon some scenarios. I will be covering those scenarios.
Okay. Okay.
Okay. There is a rack mechanism, rack awareness. We will be going through with rack awareness, which is a principle. You will be participating in that particular exercise, how to place replicas into
Okay.
different nodes.
Okay.
Okay, so with the help of this particular diagram, we can say this is perfectly fine. If a particular node is not there inside the cluster, so we will be able to recover the data from the node which is having its replicas. But try to think. Uh, Try to think in that particular direction, how this particular master is having the information that this particular node is there inside the cluster or not. What is the mechanism that he is following? So what is there, each and every node is going to send the heartbeat message to the master node, and the heartbeat message is saying, say, hey master node, I'm in the cluster. Hey master node, I'm in the cluster. That is the heartbeat message, say. Okay, and every 3 seconds these particular data nodes are sending the heartbeat message. Okay, so, and once this particular master node is not getting the heartbeat message consecutively for 10 cycles, and that is say 30 second. If in 30 second it is every 30 seconds, say, if it is not getting the heartbeat message from a particular node, then the master node is thinking that the node which is not sending the heartbeat message, it is not inside the cluster. It is going to treat that particular node a dead node. That will be dead node. And if the master node is able to get the heartbeat message, that is treated as a live node that is available inside the cluster. Now, now there are certain scenarios, say because of the network fluctuations, basically these particular nodes are connected with master with the help of the the LAN cables, okay, and LAN cables, or you can say through the internet, these particular nodes are connected. Okay, connectivity is there between data node and master node. Now, now there is certain issue in this particular connection, and the master node is not getting the heartbeat message from this particular node. Say now, what will happen after 30 seconds? It is going to treat this particular node dead node. But what is there? What will happen? So, say the master node has given certain task, say something need to be processed, and the data node was having certain task in order to process some data, and this task was performed. It is keep on performing that particular operation which was given by master node. But it is not able to share the status because of the network fluctuation, but it is going to perform the operation which was given. Now, if the master node is not getting the heartbeat message, what is the responsibility of this master node? It is going to divide the task among the rest of the nodes, so say data node was doing something, so that particular task is given to the remaining node inside the cluster, you can think in this particular way. One task was there which was given to this particular node, and it is not able to send the heartbeat message, and master node has treated this particular node as a dead node, and master node has done what? He has given that task to data node 2. Okay, now two nodes are working onto the same data. After some time, what has happened? The data node 1 like sent the heartbeat message, and the master node like observed that two machines are working onto the same data. Two machines are performing same task. Okay, now, what the master node is going to do? You can think in this particular way, like you are having you are having 10 persons, and you have divided certain tasks, and like what you have observed, like say one person was not performing task, he was not able to connect with you. Now you have given that task to the remaining persons or another person, and one person is performing two tasks, and another person is not performing based upon you. Now what you are going to do, once you are going to observe like one task is performed by two persons, what you are going to do as a
I
master,
will
what you are going to
I
do?
I will ask one of them to stop that task.
Yeah, to whom you are going to stop?
Ra- I will randomly choose one of them.
So over here, Masternode is doing what? Uh, he's not stopping anyone. Masternode is not stopping anyone. He's just like waiting for the outcome. And the node which is saying, say, hey, Masternode, I have done this particular task. That particular outcome will be considered. And at that moment, he's allowing the second node to stop the execution on that particular task. Right? So he's working in a smart way. He's not having the information that, like, say, first one or second one, which one is going to complete it. Although, like these particular machines are going to send the status information as well. Like, hey, master node, I have completed this much percent of the task which is given by you. Like that is the status information inside the heartbeat message. Like these machines are going to to share the status information, task processing status information as well. So his the master node is going to keep like which is going to process the data with low latency, or the machine which is processing first, that particular outcome will be considered, and the second one will be dropped at that moment. Okay, so each and everything is working in a perfect way. So this particular stuff, what we can say, fault tolerance. The recovering data, once a node is down, that particular issue is known as fault tolerance. Okay, another scenario. Okay, we are able to recover the data once a data node is down. But what will happen if master node is down?
I think one of the data node will act as a master node.
No.
But how the status will transfer from master node to data node? Status like job status and all details and metadata.
That is a good question. Okay, so over here, like what we have seen, there are two components in the Hadoop ecosystem, or inside the Hadoop. What we have seen, name node and data node. That is perfectly fine. But we are having third component as well. That is secondary name node. Okay, secondary name node. So secondary name node is a person like which is also known as a, which is the standby node basically, or which is once a particular master node is down, that particular node is going to take the responsibility of master node, and then it is going to handle the cluster. Okay, so we in a particular cluster, in a Hadoop cluster, we are having secondary name node as well, which is nothing but a name node only, or standby name node only. Once a particular master node is down, then it is going to take the responsibility of master node, and it is going to serve the cluster. Now over here, the name node, once the name node is failing, the Gaurav has said like the data or the status information or metadata related stuff that will be lost. And if this particular data is lost, then we will not be having the information in which node what is happening. We will not be having the data like which data is maintained in which node. So that particular metadata will be lost. So we one thing is there, like once we are designing the Hadoop cluster, then we are going to create the master node with high quality hardware. High quality hardware, like where we can say that will not be failed, that is having least failure rate, that will be having high availability and all, that is new hardware with updated stuff and all. So master node is prepared in such a way so that like the connections and all that will keep live inside the cluster. And if we're talking about the data nodes, that is based upon the commodity hardware, like we can compromise with the quality, with the configuration of the nodes, but over here like the focus is high quality hardware. Once we are like allowing a particular node to be a master node or name node, master must be having the good configurations, good quality hardware. So the very first issue that once a meta master node is down, we will not be having the metadata. And if we are not having the metadata, then we will not be in the stage to connect with the data nodes inside the cluster. If a client is coming, to which to which machine the client is going to connect in order to transfer the data, we will not have that particular information. So in order to tackle with the situation, we are having say secondary name node. And secondary name node, like secondary name node or standby machines, we used to say in almost in each and every field. And if a particular active one is down, then the passive one is going to take the responsibility, and we will be able to handle the situation. We will be able to handle the scenario, and normal functioning will keep on going. But the main thing is that how that particular normal functioning will keep on going once a particular master node is down. If master node is down, then how the status will be transferred from master node to secondary node, so that the normal functioning will not have any impact. Okay, so for this particular issue, what we are having two main things, that is edit log file and fs image. These are the two files which are playing a critical role in order to maintain the normal functionality. Okay, what will happen when a master node is down? Okay, once a master node is down. Okay, so master node uh, and secondary node. Okay, master node and secondary node. So master node, that is having the status information, and secondary node, that information like which is there inside the master node. This particular node need to have that particular information like metadata and all. Metadata and all. Okay. Okay, this particular information need to be transferred inside the secondary name node, so that the normal functioning will keep on going. Okay, and what we are having edit log file and fs image file. Fs image file. These particular files are responsible for transferring this status information from master node to secondary node. For transferring this particular status information, we are having these two files. Now you can think in this particular, I used to quote this particular example multiple times. So what is the data which is maintained inside both of these two files? So say a cricket match is going on. Example of cricket match. Cricket match. So once a match is there, and say India is playing, and the score is say 148 for 2, and say Rohit Sharma is on striking end. Rohit Sharma is playing. Uh, he's batting and he's on striking end. The score is 148. The scoreboard is displaying 148 for 2, and Rohit Sharma is hitting high, and like at that moment what we are having three consecuting four. So at that this moment, like after three balls, once the score board was displaying the score 148 for 2, after that we are having three fours consecutively, three fours are there, and the score board will have 160 for 2. Okay, consecutively three fours are there, and then the scoreboard will display. Okay, 160 for 2. So at a particular instant, at a particular for a particular duration, once the scoreboard is captured, scoreboard information is captured, that is the content of edit log file for a particular instant. After this, what are the other, you can say, uh, transactions, or what are the other, you can say, details, those particular things are captured inside the fs image. And once we are going to club this particular score and the new transaction, then that is going to to provide me the updated score. Initial status, once the score board was captured, then the new hits from Rohit Sharma, both of these two scores or transactions are being captured, and then the new score uh, that will be 164.2. Okay, so that is the data. Now just try to see this particular diagram. Over here, what is happening? Edit log, okay, edit log file, this is the primary name node, okay, this is the content of master node. These particular files are maintained inside the primary node, so these particular files are moved inside the secondary name node, this is standby node or secondary name node. Okay, these particular files are moved on. This is 148 for 2, then consecutively 3 fours, and both of these two files, okay, or scores or transactions are merged together, and we are having new score, and then that particular score is moved inside the shared memory, and like meanwhile this particular process is happening, checkpointing, like every 30 seconds this particular stuff is being performed, so at every 30 seconds this uh, edit log and fs image file are merged together and kept inside the shared memory, and every 30 seconds it is going to replace the file which was placed earlier, so fs image ckpt is going to replace fs image ckpt older file, and then every 30 seconds this particular score is maintained, what I can say. Now within this particular durations, once this particular checkpointing is happening, it might be possible like there are certain change inside the score, that is captured with the help of edit log file edit.new, and that particular file is moved directly inside the shared memory, now, once a particular primary name node is failing, once a master node is failing, then the secondary name node is going to pick these files from the shared memory, edits file and fsimage file. Okay, and it will start working, and the normal functionality is not impacted at that moment. So these particular files are responsible for maintaining the normal workflow inside the Hadoop cluster if a master name node is failing. Okay, just have a look and ask if you are having any doubt. All of you.
Ashok, this shared memory is on a different machine.
Yes, that is not inside the name node. It is shared memory. You can say like we are having a disk uh, where like this primary node or secondary name node both are able to access.
Means it's different from primary and secondary node both.
Yes, 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 yes.
Okay, okay,
Okay.
Can you
okay.
please explain again? Actually,
Okay.
I'm confused.
Okay. Okay. So what I have said, like we are having two files, edit log and fs image. These particular files are responsible in order to maintain the status, normal functioning or the metadata, each and everything is maintained in these particular files. Current information, okay, that is maintained, or a information at a particular instant that is captured inside the edit log file, and after like capturing the status, if there are certain change that is captured inside the fs image, I have quoted it with I tried to I have tried to describe it with the example of a cricket match, and say scoreboard has captured the score like 148 for 2, That is the current content of edit log file. Now, after this, like Rohit Sharma hits three consecutive fours and three consecutive fours, that is nothing but new content, new content or new transactions. So that is the content of FS image file. And what will be the total score if we are going to add edit log content and fs image content? So that will be 164.2, and same we are able to see over here, at a particular instant the data which is captured, that is there inside the edit file, edit log file, and once the status has been captured, and after that particular status, if there is certain change, that is captured inside the fs image, those particular files will be moving inside the secondary name node, and over there the checkpointing will happen, checkpointing, that is like adding both of these two files, that is, you can say, total score, 148 for 2, that is the content of edit log file, and 3 consecutive 4, that is the content of fs image. So both of those particular data will be merged together and a new file came into the picture, that is fs image check ckpt, fs image checkpointing, and that particular file will be moved inside the shared memory, and it is going to replace the older one, okay, with this particular current file, which came from this particular checkpointing, so we are having new fs image file that is based upon the the score, current transactions, and the image or the snapshot which was captured, so at every 30 seconds this particular process is happening, and the data, the fs image ckpt is moved inside the memory. But during this particular duration, if there are certain transactions, if there is certain change inside the edit log, edit file, that particular data also moved inside the shared memory. Now we are having edit file and fs image. Based upon these two files, the status will be maintained, and if this master node is failing, then the secondary name node is going to pick these two files and it will start the normal functionality.
Ashok, it means that
Yeah.
a secondary name node will compare the current edit log with the edit log which is located in the shared memory. If those are different, then it will merge again. Huh?
Over here, merging is happening inside the secondary name node, that is perfectly fine, and it is going to replace the older one inside the
In
shared
the
memory.
shared memory.
Yeah, it is going to
Okay.
replace inside the shared memory, it is going to replace, just replace, nothing is happening with respect to checking and all, huh? It is just going to replace the
Okay.
older one with current one,
Okay.
right, Gaurav?
So, yeah, so get it.
Okay, perfect, huh? So this is the way, like how we are able to tackle the situations once a master node is down. Okay, and we will be able to move with the normal functionality. Yeah, this is the way. Now, just tell me, like if the secondary name node is also down, who is going to help us?
You mean to
Data
say
is
that
already shared in the memory
pri-
shared.
Who is
primary and
going to
secondary
help?
node both?
But I need to start with the functionality. If I'm having the nodes only and I'm not having the master, master is not available inside the cluster. I have not aligned a node to act as a master.
And cluster will fail in this case, I think.
Yeah, nobody will save us.
Only God will save us.
Only God, God can save us. Yeah. So I think that's it for the day. Okay, and I will share certain links in order to do the installation, and I will connect with you during weekdays in order to set up the environment. And from the next session onwards, we will be working on to the SDFS and Linux commands uh, to perform these particular things, to get the flavor what we have seen in today's session. Okay, so from next session onwards, we will be having like stuff from the practical point of view. We will be going through with installation and writing down the commands and all. So that we will start from the next session onward. That's it for this particular session. Let me stop recording and take your queries if you are having certain queries.